In this video, we're going to look at the different types of formulas that you can have in organic nomenclature. You can have one of three different versions depending on what you're reading, and I want you to be able to convert, if you will, between the three different types. So we're going to look at condensed, molecular, and structural formulas here in a minute, but I want to talk briefly. Depending on what type of molecule you're looking at, you will have a different structure. So what we're going to do is we're going to look at the structure that's based on carbon with an N ratio of numbers, and hydrogen, which is going to be 2N plus 2, for our example, and these are alkanes. So as I mentioned before, you can have molecular, structural, or condensed formulas, and they all tell you the same thing, they just show it to you in a different way. So we're going to go back to that C to the N, H to the 2N plus 2, and we're going to go with C3 and H 2N plus 2, so 2 times 3 is 6 plus 2 is 8. So the correct formula that we're going to do in the example here for molecular is C3H8. So this is telling us that our formula has 3 carbons and 8 H's. That tells us some features like the mass and that it's an organic molecule, but it doesn't help us understand how it's connected. So in order to do that, we need to be able to have a structural molecule. Now, remember, carbon is going to form 4 bonds, okay? And hydrogen is going to only form 1. And there are other atoms that can be involved, but right now we're just focusing on carbon and hydrogen. So we have to have 3 carbons in this image, and that's what our formula tells us, and we're going to have 8 H's, keeping in mind that carbon wants 4 and hydrogen wants 1. So we're going to have a hydrogen here, and we're going to have a hydrogen here. We're going to have a hydrogen on each of the 4 sides that are available of each carbon. And if you look at the end result, you have 3 carbons and you have 8 hydrogens around it. So that's the structural formula for C3H8. Now, the condensed formula looks sort of like this. You're going to take the information provided to you around each carbon and you're going to condense it. So in this first carbon, we have CH3. And in the next carbon, we have CH2. And in our last carbon, we have CH3 again. So this is the condensed structure of C3H8. So you can see that they're all giving you the same information. It's just shown differently to give you different information and make it maybe easier to write in a textbook or to understand what it is you're working with. There is one other version of a molecular formula, structural formula, called the line, or sometimes it's called the ball and stick. And what they do in this version is they are just showing the carbons with lines. So in this example, we're going to have an imaginary carbon right here. And you're going to have the bond shown between each carbon. So we're going to have that first line, the second line, 1, 2, 3. And at the end of each of these lines is a carbon. So we are showing this one as this bent picture right here. We would assume that, and I'm going to draw it in because it's easier to see that, we would assume that we have a carbon here, a carbon here, and a carbon here, and each of them are fully filled in with hydrogen. So we'd have 1, 2, 3, 1, 2, 1, 2, 3. So the line drawing of the CH3, CH2, CH3 is this bent line. And we know that at each bend, you have a carbon. That one's a little bit harder to look at, but you will see them in textbooks. Another example I want to give you looks like this example on the right that I've just drawn in. So there's a couple other things that are going on here. You have this this chlorine attached, and you then have you have a longer chain. So I want to show you what they can do with a longer chain. What they do is you are going to list the first one, CH3, and then we have this carbon with a hydrogen and a chlorine on it, okay? Then we have this these 2 CH2s, and some books will show you CH2 condensed even further in parentheses. And then we have that last CH3. So you can see that there's lots of variations on a condensed structure. You can have other features included. I wanted to draw that in black. You can have other features included. You can represent them with parentheses to help you see a repeating pattern, anything to make the formula shorter.